In this lab, we observed and tracked the motion of a roller coaster. We created the model to observe the possible forces at work and get accuracy, and then we tested the validity of the number of g-forces claimed to be experienced on the ride. We found that in our model, where no drag force was accounted for, we had the most accurate data compared to our experimental data. This means the force of gravity was so strong that it completely canceled out the drag force and set the cart in a 1G state. The roller coaster I observed was Kingda Ka from Six Flags Great Adventure. It drops 139 meters at a speed of 57.2 meters per second. The math was a little bit tricky for this problem because it can change depending on how many people are in the cart and the weights of the people on the cart. So I used a scenario found from the Six Flags Georgia workbook where the mass of the cart and the people inside it were 8,325 kilograms. This was the base for my program throughout the lab. So G-force is the force exerted on an object by the Earth. At 0G, you have a feeling of weightlessness. 1G is your regular body weight, and 2G is twice that, 3G, etc. Kingda Ka claims to have a 5G experience for the rider. To get an idea of how strong this is, NOVA website says fighter pilots need anti-G suits just to experience prolonged periods of 8G. So I found a video on YouTube that tracked the cart as it goes over the loop and down. I began tracking at the top of the loop as it was falling down at its fastest velocity. I used the height of the roller coaster to calibrate so that we were measuring in meters. And then I tried to align the axis along the Y so that it was mostly the only thing changing. However, this video is not the best quality and the frame does shift a bit towards the end. So this will cause our data to be a little bit inaccurate. So for our program, we can look where we found that the initial position and settings of the vector were just used from the tracker program that we had recorded. We used the change in y position over change in time to get the initial velocity. And then we did different things to get different experiences out of the roller coaster of what we wanted. For example, to experience 0G drag force, we knew that the G force must cancel out with the drag force. For the mass given, we were able to calculate the value for B, which would be needed to get this 0 net force, shown here. We ran that, and then once again, we did different things to get different experiences. For example, to get 1G, we knew that the drag force would have to cancel out, so we canceled out the B values and only worked with the W. And we knew that our W force was equal to the mass of the ball times the gravity 9.8. Then to get the 2G experience, all we did was multiply this value by 2, again with the rest of the drag forces canceled out. Here our results are shown of all the different scenarios that we tested. We found that the model with no drag came closest to the experimental model. This is also at the same level or equivalent to a 1G force. This means that the coaster goes so fast the drag force gets canceled out and the full force of gravity is felt. Some errors in this lab show that the lab failed to meet the model effects of an individual's experience. It only models the effect of the cart itself. From this experiment, we cannot verify whether or not a person feels 5G force. However, the cart, which is about 8,325 kilograms, was able to feel the full force of gravity exerted on it. So it's very plausible that an individual of much less mass is going to feel an even stronger force of gravity. Other errors which have already been introduced are the mass of the cart varying, especially depending on where you're sitting on the ride. Also, the video is not steady, the axis changes, so our data may not be completely accurate. Also, roller coasters are super complex. The cart is not a point mass. The friction of the wheels work in multiple directions. There could also be brakes added on and different safety features for this roller coaster. So in conclusion, our model failed to tell us about the effects of the individual, but we saw that the cart of the roller coaster experiences full gravitational force at its fastest speed. We also found that many more complex forces are needed to be accounted for in order to create an accurate model. Thank you for watching.